Hello, Izan Holicity, the IT guy. Today I'll be answering the Software Regional Mock Examination 20K20 Ordinary Level Computer Science Paper 2. If you don't have this question paper, make sure you click on the link below to download this question paper and follow along with me. Question 1A. In the manufacturing of a car, the company builds a model and then the prototype of the car. Romans 1. Explain the term model as used in the car manufacturing industry. Okay. Let's first of all understand what is a model. A model is a non-working miniature representation used to illustrate the product. E.g., a car is shown beside in the manufacturing industry. Okay. If you come, for example, to a manufacturing industry and you guys, or you're working there and you guys want to produce a car, the first thing you're going to do is to produce a model. A model is a miniature, that's a very small representation of that car you want to produce, a non-working one. A good example is like during the Christmas season, the Christmas period, the Christmas break, most of your parents buy you these toy cars. That's a miniature or a non-working version of a bigger car. You can look on your right here. This engineer is producing this small yellow car. These are some others here. These are miniatures of the cars that are to be produced. From there, we go to what is a prototype? A prototype is a first or early version of a product from which other forms are developed. From the model, we then move to what we call the prototype. That is, you reproduce or you produce the very first version of that product, the early version of the product. That will be tested. That version will be tested to correct errors. Don't put something that will cause a disturbance on the road. Like this car, as you can see, this car is a Google self-driving car. We have never heard of this before, but it exists. It's not been commercialized at this point because it is under a test. This is the very first version of the car that is out. It's under a test to correct all the errors that are found on the driving system. You not like to get into something that is driving alone and you go and knocked up by a tree, or it carries you, or you say go to east and it goes to west. No, so we have to test all those things to see if the car's brain, that is, the memory, is responding very well. If you succeed in producing it and it responds very well, then now we start reproducing other versions or other types of this same car to deploy in our market. I think that one is very clear. 3, give 2 advantages each of producing a prototype and a model. Okay, for a model, improving system understanding through visual analysis. Yes, when you have that small miniaturized version, you can improve your visual analysis, improve your system understanding by visual analysis, looking at it. Discovering errors earlier and reducing system defect. Yeah, when it's small in that miniaturized version, you can easily identify which parts are to be connected to which part. If the part is not well connected or fitted, you will know what to do when you are producing the prototype. For the prototype, more opportunity for changes. You can easily change, low development cost, quick testing of product. Because when it's in that first early version, you can easily do so many things like the one listed here. Okay. 1D, describe briefly how each of the following methods can be used to ensure unauthorized access to data. 1, biometrics. 2, encryption. Good, let's start with biometrics for us to first of all understand how you can use that to secure data. Let's get a definition. Biometrics are ways to measure a person's physical characteristics to verify their identity. This can include physiological traits such as fingerprints and eyes, facial patterns, visuals, etc. Okay, let's take an example. This is a warehouse, a data warehouse. That is where we store massive data, important data. To get into this building, you need to pass through an opening, which is a door. It will be a well-secured door. And that opening now will have what we call a biometric system, a system that will be installed to check your physical characteristics on you, either your eyes, either your facial pattern, voice recognition, fingerprints, etc. Without that matching with what is stored into that system, you will be unable to access this data center. These are the various characteristics here to be checked if you observe very well. Meanwhile, data encryption, how does it function? Data encryption translate data into another form or code so that only people with access to a secret key, formerly called a decryption key or password, can read it. Okay, with this case, it's like I want to send you a text message. I've sent you money, and I want to send you a text message to give you the code for you to withdraw that money from the bank. Okay, my message will be your money withdrawal code is God is good 123. When I will send it via the internet or through any other means, what happens is there will be a key called an encryption key that will change this plain text here, this plain text here into what we call a cipher text. A cipher text is made up of characters. That is that the plain text will be converted, totally translated to a group of characters, a chain of characters called string, which those who don't have the keys cannot understand. So you with the key, when it comes to you, you have to decrypt it because decryption, and you get back to the plain text. So from here, you understand that biometric deals with the physical characteristics that will be checked by the biometric system, whether encryption is dealing with keys to encrypt and decrypt the data. That will help us to protect our data from unauthorized access or unauthorized users. C. Study the algorithm below and answer the questions that follow. Step 1, I've added some steps there. Step 1, start. Step 2, take any value and start it in n. Step 3, check any value. If n is greater than 0, then go to 5, else go to step 4. Step 4, check n value. If n is less than 0, then go to step 6, else go to step 7. Step 5, if you just continue reading, you'll get that. The first question that says, give 2 characteristics of a good algorithm. I've given 4. The first one I've given there is small running time. Let's consider these 2 algorithms here. Look at this algorithm written in Pascal. Program small time begin. You have right line hello, right line hello, right line hello 6 times. Read line n. Then look at this other one, the same thing. Program small time. Variable I is an integer I. For I equals to 1 to 6, do right line this. So if they present this algorithm to you, let's assume that I want to write hello 1 million times. And use this first one here, it means that you write this right line 1 million times. Meanwhile, here with this other one, you write for I equals to 1 to 1 million. Do right line once. If you run these 2 algorithms with 1 million, this one will take more time than this. We have to read this thing, and it takes you more time to write this type of algorithm. So you always have to write in right line, hello, right line, hello. Meanwhile, with this is shorter. You have to have less memory usage. Yes, a type of algorithm that when it runs, it uses less memory of your computer system. There are some complicated algorithms that will consume all of your memory and make your machine to be very slow. An algorithm should be able to solve a problem. Don't write something that will have nothing to do with just a mad algorithm, just be going north, south, east, west, no direction. An algorithm should be final. finite, please. An algorithm should be finite. You have a start and an end, not a stupid one, but a finite algorithm. Not something that is just continuous, infinite, continuous, running from day to day without any end. The next question, represent the above algorithm following a flow chart. Good. Represent an algorithm following a flow chart. This algorithm here, this step 1, 2, 3, 4, up to 8, let's represent using a flow chart. Okay, start. Yes, I will start with the symbol over. Take any value and store it in N. Yes, you should read N. That is, it takes and it stores it into your memory, into your RAM as N. The first condition, if N is greater than 0. Yes, which means that it's positive, it's accepted. What should it do? Give number as positive. Given number is positive. Then it ends. After this, directly it ends because it's written on the paper. Given n value, if n greater than 0, then go to step 5, else go to step 4. Good. So either it ends or it goes to step 4. Here is step 4. Step 4 is the no part of this n is greater than 0, which is n is less than 0. Now here we have two conditions. If n is less than 0, true. Given number is negative, it ends. Because if n is less than 0, it means it's a negative number. The algorithm will print given number is negative, it ends. Else, if it's not less than 0 and if it is not greater than 0, it obviously means it is equal to 0, which is the no part of this statement. And when it's equal to 0, the algorithm will print given number is 0. Then from here, it ends. All algorithms need to end because we follow, it's a step-by-step representation of a method to solve a problem. So it starts here and it ends here. So with this, I come to the end of question 1 of paper 2, Southwest Regional Mock 2020 ordinary level. In the next session, I'm going to answer the question 2 of this same paper. So just stick on and you click on subscribe and like. Thank you.